Hello and welcome to another video tutorial on how to use C++. Today we are going to talk about how to manage data that is stored in our hard drive in appropriate structures. And by structures I mean the user-defined data type struct. Okay, for this we are going to create a new project named Struct. Then the usual, add a new element. This is going to be our main, and then our standard structure include IO stream and using namespace and our main function. Every data that is processed by a program is managed in the main storage. And storage space can be requested for integrated data types like ints, doubles, or characters, and the values can be saved and changed under their variable name. So let's imagine we have a variable integer, an integer called number. Then this is our data type, and this is the variable name that we can access the value from. To save multiple values of the same data type, we used arrays or vector containers before. And with these, we can manage scalars or vectors. But in many cases, in real life, objects consist of many different parts that, as a whole, create a sufficient description of an object and not by every single one. So let's imagine we have a point with an x and y coordinate and also a point number. So for the point number, we could imagine it has an integer, and for x and y coordinates, a double. And now I want to show you how to create a user-defined data type with a struct. For that, we move outside of our main function and define this with our keyword struct. So this is then our user-defined data type, and the name of it is point2d. So then we open the curly brackets and we can see that the semicolon here has been added automatically. But let's put a comment here first that says simple user-defined data type for a point in a plane. So what does a point need? As we said, it has a number, an integer. Let's call it I number. Then we have coordinates, doubles. So we have a double x coordinate and a double y coordinate. Then that's basically it. These three variables are called element variables. So let's put this here, and then don't forget the semicolon at the end. And now how to work with this. Okay, so we can go back to our main function, and just like we created an integer in here, we can now create a point. So to do that, we type in the user-defined data type, which is point2d. And then we have to set a name. Let's choose p1 and add a comment. So what we did here was we created a variable of a type point2d. And now to assign values to each element variable of our point, we first have to access every single of these element variables via name and then point operator. So you can see here that if I type in point, then there's a lot of suggestions, all these that we set before, to which I should assign a value to. So let's choose number is 1, and then for 0.1 x coordinate, let's choose, because we have a double, let's choose 5.5. And for the y coordinate, let's choose 4.5. And let's put this into the output. So we say cout, and then the x coordinate of 0.1 is, and then the variable name. And we do the same for the y coordinate. And then let's see what it looks like. So let's run this. And we can see that it was successful. We have the x and y coordinate written in the console. Okay, so the advantage of such self-defined data types is the simple handling and the better understanding if we have implementations for it. But the disadvantage is that for standard data types, there are already some implementations for some calculations or outputs, but not for our self-defined data types. This means that we have to create new implementations. For example, we don't have the possibility here to get an output of our 3 element variables just with a function. So we would have to do that first by ourselves. And to get an idea what I mean, we just try this. So we build a function named void echo point to d, which gets assigned a point to d and a point via a reference. Then all this function does is written here. So we just get an output cout of our point number. So we just write p and then the p number. And the second output is then just the coordinates. So we say here it should write all values of our element variables x and y in brackets. So we have p.x and p.y separated with a comma. Then close the brackets, end line, and then just add in the main the function to have another output just to compare it to the other output we already have. So let's say echo point to d of 0.1 and run this. And then our output says here we have the point number p1 just as we defined it, and then the x and y coordinates in brackets. Yeah, so this is what I wanted to show you, that for all different types of cases we can create a self-defined data type and assign values for the self-defined element variables in them. And then, of course, we can also calculate with them or have them in the output. What we also can do is to write these self-defined data types into vectors. This can be done if we include the vector library and then create a vector that should work with point to d. So just write vector and then point to d, and we just name it points. So if we want to work with multiple points, then we can just write it into a vector. So if we run this, then there's no error. I just wanted to show you this. I don't want to continue working with the vector right now. So that's it for today. I hope you got an idea about how to use self-defined data types. and thank you for your attention.